In this video, we need to solve this equation. This is a rational equation. We have rational functions here, and we need to come up with our solution. When you go through and do a problem like this, there are a few different ways that you can do the problem. One of the ways would be to look at all of the different fractions that you have on each side of the equal sign and determine what that least common multiple would be, which would be the same thing as the lowest common denominator. So you can think of that either way. In this problem, this x is over 1. Here we have 10 over x, we have an x on the bottom there, and 3 over 1. So our denominators right now are 1 and x and 1. And if you were going to determine the least common multiple, or if you were going to think about what the lowest common denominator would be, if you're going to add or subtract all of those with a 1 and an x and a 1 on the bottom, that lowest common denominator or least common multiple would be an x. Once you've determined what the least common multiple would be, then one way that you can go through and solve this problem is for us to multiply everything on both sides of the equal sign by that value. The advantage of that is very quickly you won't have any fractions left at all. Before we get started, we might want to list out any excluded values. So taking a look at these denominators, we have a 1 in the bottom of this fraction. This one has an x. This is 3 over 1, so 1 again. There is the possibility that we might end up dividing by 0 because some of these fractions have variables in the bottom, specifically this one. And we can't divide by 0 or we get an error, so we need to exclude values. In this case, just a value, and it would be the number 0. So in this problem, x can't be 0. When we go through and solve this and we get to the end, if 0 is a solution, we are going to need to get rid of that. So we want to make a list of our excluded values before we go through and solve. You could also do it at the end, but a lot of times it's easier to see towards the beginning and then do the problem from there for solving. Okay. So here's what I'm going to do in the next step. I want to multiply everything here by x. I'm going to spread these out a little bit. When the book does this, they leave space behind. You can leave space behind or in front. It's up to you how you want to do that. I'm going to go through and do it the way the book does it. I'll leave space behind each value. So the first term that we have here is an x, and then I'm going to leave a little space here, and then minus 10 over x, and I'm going to leave a little space there. And then we have our equal sign with a 3, and then some space behind. So that's the exact same thing I had in the line before. And then what I'm going to do now is I'm going to multiply each of these 3 values, multiply both sides of our equal sign by that least common multiple, which is an x. So I'm going to multiply this side by x, multiply this side by x, and multiply this side by x. Now when I do that, what we want to do is cancel out any fractions that we have. So if you look at this first multiplication, there was nothing in the bottom of the fraction, just an invisible 1, and x times x is x squared. So we're going to have an x squared for this first term. And then we have minus 10 over x times x. These x's here, we have an x in the top of the fraction and an x in the bottom. Those are going to cancel each other out. So we're just going to end up with a minus 10 once we simplify that multiplication. And then on the other side of the equal sign, we have 3x. So in a matter of a couple of steps, we no longer have fractions, which makes this quite a bit easier to solve. From here, here's what I see. I see we have an x squared term and an x term, so because we have an x squared term here for a highest power of x, that's a quadratic. In order for me to solve the quadratic, I have a few options. But if you're going to factor, or if you're going to use the quadratic formula, putting this into standard form equal to 0 is what we would like to do. From there, we could, again, factor a quadratic formula. There are other options, but those are probably the two most common. This looks like it's going to factor pretty easily because I can use the shortcut. There's nothing in common with those three terms. Looking for two numbers that add to be -3 and multiply to be 1 times -10, which is -10. Those two numbers are -5 and a +2. Outside the parentheses now, there's no addition or subtraction, just multiplication. We have two things multiplied together that equals 0. So using the zero product property, can break that up into two parts and solve. So there are two possible solutions here, but anytime that you multiply both sides of an equal sign by something with a variable in it, like we did in this step, we could end up with extraneous solutions. So we need to cross-reference these solutions or possible solutions that we have with our excluded value or values. And if any of our solutions are on that excluded value list, then we need to get rid of those off of our final answer. But the only excluded value we have is 0. 0 is not one of the possible solutions. So both of these would be included in our final answer. Here's another equation involving some rational functions. In order for us to determine what the least common multiple is, we are going to need to have these in a completely factored form. So looking at the three denominators, I want to factor those if I can. The x minus 8 does not factor. I'll put that in parentheses to show that I tried to factor it, but it did not factor. 2 is just a monomial, just a single number, so we don't have to worry about trying to factor that, and we do have that x minus 8 on the other side. So looking at those denominators, no factoring involved there. At some point, I'm going to want to list out my excluded values. The bottom of this first fraction is an x minus 8. What would make this denominator 0 is that if x were 8. So x cannot equal 8. Otherwise, we would divide by 0. This fraction has a 2 in the bottom. Don't have to worry about dividing by 0. It's always just the number 2. And here, 8 again would be our excluded value. I also want to take a look and see what our least common multiple would be. Once you have these in a factored form, you can just kind of inspect all of those denominators and figure out what that least common multiple would be. I have a factor of x minus 8 here. There's another one here. If you have a factor that's repeated in more than one denominator, you pick the one with the largest exponent, but this is an x minus 1 to the first. So the exponent there is 1. This is also an x minus 1 to the first. So an x minus 1, this is an x minus 8 to the first. Exponent is 1. Here's another x minus 8 to the first. So with these x minus 8s, the first power is our exponent, and they're the same. They're both to the power of 1, so the bigger one would still just be an x minus 8 to the first power. And then in our other denominator here, we have a single number. There aren't any other numbers anywhere that are just individual numbers in the denominators. So we are going to need to have a 2. Usually we'd write that 2 first. So 8 is going to be our excluded value this time, and our least common multiple is going to be 2 times an x minus 8. I'm going to rewrite what we have here in the previous step. And I'm going to leave some space after each one of these. And then I'm going to multiply by our least common multiple. When we're multiplying by this least common multiple, it does go on the top part of the fraction. It's over 1. I'm not going to put those 1s there. But it is over 1. Okay, so in this first fraction here, we're multiplying by 2 times x minus 8. I do have an x minus 8 on the top and the bottom, so those would cancel. So we would end up with a 2x minus 5 times 2 there. In the next fraction, we have some 2's here. That would cancel. So we have an x times an x minus 8 there. And then in this last fraction, these x minus 8's would cancel, leaving us with an 11 times 2. Getting rid of some parentheses here, distributing this 2 in, gives me a 4x minus 10. Distributing the x in here, plus x squared minus 8x equals 22. I'm going to set this equal to 0, so I'm going to subtract a 22 on both sides, and when I write down the terms over on this left side, I'll combine like terms and put this into standard form. The only x squared value I have here is this x squared. For our x's, we have this 4x minus 8x, and then for just our constants, negative 10 minus 22 is a negative 32. Using the add multiply method, looking for two numbers that add to be negative 4, multiply to be negative 32. That would be a negative 8 and a positive 4. So using our shortcut, that would factor into an x minus 8 times an x plus 4. Outside the parentheses, we do not have any addition or subtraction, so I can set each one of those equal to 0 and then solve. So our two possible solutions are 8 and negative 4, but back in this step here, we multiplied by something with a variable in it, both sides of our equal sign, which means we need to double check and cross-reference our possible solutions with our excluded values. And x in this problem cannot be equal to 8, and that did end up being one of our solutions. So 8 actually is not a solution. If you plugged it back in and tried to see if it worked, it would not work, because it would end up causing us to divide by 0 in the original problem. So there were two possible answers in this problem, but one of them was an excluded value. It would cause us to divide by 0 and can't be a solution. So the only solution for this one is negative 4.